Let's all welcome Benjamin Herring with HTTP security headers, a technology history through scar tissue.
Hello, hello. Hopefully we'll get the slides up here in just a little bit. Hopefully you guys are here to talk about HTTP security headers. If you're looking for that, you're in the wrong room. You better run downstairs to the theater real quick. All right, anyway, let's start. My name is Benjamin Herring. I'm a SANS community mentor. I help out a little bit here with BSidesSF. I work at the company that bought you all lunch yesterday, but you're not here to learn about me. Let's move on, get to the content. First, a little bit of housekeeping things. If you are wanting to capture the slides, feel free to take photos, post them on Twitter. Don't get anybody else in the shot, but if you want to just go straight to the information, there's PDFs already uploaded to this event here in Sketch. You can follow along in real time, whatever else you'd like. Also, we're going to do questions today without this clicker. Let's try something else. All right, so if you have a question, we're trying something a little bit new here at B-Sides. We're going to do Slido. You can just open that up on your phone, enter in BSidesSF 2019, and the proctor, you can vote on what questions you want. If there's some time at the end, we'll definitely go over those. And anything else, feel free to just yell at me at Twitter. I will generally enjoy going through all the shit posting you have to yell at me once we get done with this talk. The handle's right there. But with that, let's get into the content. So, I really like HTTP security headers because they are a living record of history of all the times where people have gone and went, wait, that's super bad. And it always kind of follows the same pattern where someone somewhere finds something bad on the internet. And it turns out that in order to shut off that bad thing, it's going to break a lot of functionality on the internet. So what we always come up with is, we'll just have this very special security header that if you send it, will turn on this great security control, but it's just going to be off by default. And then wash, rinse, repeat. We keep finding this over and over again. Or to put it another way, you're a wizard, Harry! And the internet is full of terrible, terrible things. Fortunately, we have a browser that's big and strong and has lots of security controls just waiting for you. But in order to make it work, you have to know the magic words. So, here's our magic words. Here's the headers that we're going to be talking about today. And let's get straight into it. So the first one that kind of jumps up on the scene is this X-Contite top options. About a decade ago, somewhere around December 2008. All right, so what's the bad thing? So back in the day when people were building websites, browser manufacturers found that people kept on running into this problem of, why is my JavaScript just displaying as a text file and not actually running? And that issue was they had uploaded it as plain text MIME-type or an unexecutable MIME-type. So browser manufacturers said, you know what, we're going to make this super convenient for you. We know what JavaScript looks like. We run it all the time. So if you send us a file that looks like it should be executed, even if you set the MIME-type wrong, we'll just go ahead and switch that for you so everything works out just fine. Well, turns out a common security control when you're uploading arbitrary files or letting users upload arbitrary files is, upload whatever you want, but nothing that's executable. And then you combine this with this new browser feature that says, we'll take non-executable things and make them executable for you again, and surprise, surprise, you start to have some sort of problem. So, if you're going to set this header, just go ahead and set it to no sniff, which basically says, browser, don't try to guess anything, just do what you're told. And then obviously you got to set your MIME types correctly. All right, moving on. The next one that kind of shows up on the scene is this X cross-site scripting protection. Again, about 10 years old or so. And the bad thing that it tries to protect against, it's right there in the name. Now, this cross-site scripting protection is not exactly the most intelligent. All right, all it's doing is really dumb pattern matching, where if it sees something that's in the URI, and that something is also inside the HTML source of the page, it thinks, that must be cross-site scripting. Let me go ahead and filter that out. And it's stopping just the bare bones lowest cross-site scripting that you can find. Now, with that, the default of this filter setting is not what I'd recommend that you'd keep it to. The reason for that is that the filter settings are kind of so not the most intelligent that there's actually been CVEs issued where the cross-site filter is actually then used to deliver a cross-site scripting payload. In addition, an attacker it's trivial to craft a URL that knocks out correct, legitimate scripts that are supposed to be there. All you got to do is have the attacker add a query parameter, set that query parameter to be the script tag that you want to get knocked off. The cross-site filter says, oh, it's the same in both places, get rid of it. And they can selectively disable functionality in your site. So don't keep it at the default. Either shut it off entirely and say, hey, we have better ways to deal with cross-site scripting protection, or set it to mode equals block. Now, anytime I'm trying to research these kinds of things, I like to go out and see, well, how is this actually looking in the real world? So here's a couple of examples from companies with security budgets way, way, way larger than mine. And you can see they don't always agree on what the correct set of security headers are. That's because these things do need to be tailored to your organization. One thing they both agree on, though, is that the defaults suck and you should change them. So you can see that Facebook includes the X content type options, but Google on their hyper-optimized homepage does not. And their idea of that really, really basic cross-site scripting filter, Google says, okay, we're going to use it, but we're going to set it to block. And Facebook says, nah, we're going to take care of this another way. So with these things, you do have to understand the very specifics of your website. Now, moving on, the next one that we see is that X-frames option that you saw in that previous example. This is a little bit newer, maybe 8, 9 years or so, something like that. And basically, it's all about embedding websites in other websites. The frame tag that this was named after is now deprecated, but this applies to iframes and objects, which I think iframes, even though the last time I touched them was embedding some Facebook social media feed like 8 years ago, I don't think it's ever going to die. It's going to be with us forever. And the bad thing is obviously if you have a good page embedded inside an attacker's web page, well, then the attacker can do all sorts of nasty stuff. So unless your website or web application is designed to be embedded into other people's pages, you probably don't want to let them do that. And that's what X-frame options does. So some common good settings are just shut it down, straight up deny. Or use same origin, which says, hey, you can embed this, but only on the same domain that it was loaded from. None of this cross-site embedding. Or you can do a very, very specific whitelist with the allow from directive. All of those will give you some more security here. That said, spoiler alert, content security policy, which we'll talk about right at the end, is way better than all of this. It's way more customizable, way stronger, but it's not really interpreted well with older browsers. So if you have a public-facing site on the internet and, like me, have a depressing percentage of your visitors still on Internet Explorer, you're going to want to send both the X-frame options and the content security policy header to make sure that you have something that all browsers actually understand. Next up is strict transport security. And this is one that I really enjoy because it's around the time when we realized that we didn't have to have X in front of every single custom HTTP header. This came out of Moxie Marlinspike's demo of SSL strip at Black Hat in 2009, I believe. And in order to understand what's going on here, let's do a walkthrough of what a normal simple browser request is supposed to look like. All right, so you got your client. The client wants to go to example.com. They type it into their browser. Simple DNS resolution lets them know the IP address. And the default of every single major browser is something that the user happened to type in rather than click, is we're going to start over HTTP, over an unencrypted session. So any major server, modern server built in the past 10 years is only listening on HTTP to say, oh, whoa, wait a sec. Let's redirect this conversation back to HTTPS, which should work just fine. The browser is going to honor it. You're going to do that TLS negotiation and dance with public and private keys. I trust it. Awesome. Here's the content way to go. Now, that's if everything's working great. But let's assume that there's someone not so great. Surprise, surprise. That's large chunks of the internet. So if you have someone not so great, a person in the middle attack looks like this, where the client still requests that domain, and they can just straight up and lie about the DNS resolution. Okay, again, the default is going to go over HTTP, but remember, the server's only going to respond with content over HTTPS. But for the person in the middle attack, that doesn't matter. It will communicate with the server over HTTPS, doesn't care about anything, just grabs the content, and then on the way back inserts whatever little malicious tidbit it wants, and the end client is going to get that and going to run it. Because even though the server thinks it's only communicating with clients over HTTPS, the or the person in the middle is able to downgrade that to plain text HTTP. All right, so how does strict transport security help with this situation? All right, same deal. Client can look and still get a faulty DNS record. The attacker can still totally lie. Strict transport security doesn't help with that. That's a different set of security controls that people are working on. What it does do, however, is if it realizes that strict transport security is set for that site, it will do an internal redirect to HTTPS before the request ever leaves the browser. At which point the attacker can send a garbled cert or whatever, and you're going to get a cert mismatch. And in addition to your regular cert mismatch, if strict transport security is enabled, it's much, much harder for the user to just stupidly click through and be like, yeah, okay, whatever. All right? So if you're going to be setting this for your site, here's what you're going to do. The basic version of strict transport security is just max age equals expires times in a number of seconds. And every single request after that initial headers respond until the time expires is going to be over HTTPS. Now, the next level that you can get with that is adding that little the include subdomains flag. And for include subdomains, if you're responding with that at the root of your site, example.com, then the browser is going to treat that strict transport security header for all of your subdomains, mail.example.com or www.example.com or foobar, whatever .example.com will get the same strict transport security header. But here's the thing, these two versions work great at protecting your end users, the end clients, for the second request onwards. It can't protect that client from the very first request. If you still have a man in the middle, that very first request might not realize that strict transport security is enabled for your site, and on the way back, the attacker can both strip out the strict transport security header and still downgrade it to HTTP. And so the way that we've decided to do this is by strict transport security preloading, which if you do all of the requirements, basically every single subdomain on this domain is going to be HTTPS enabled with a valid cert. You can get a max age over a year. You can then submit this to the browser manufacturers to have it preloaded. And preloaded basically means you add your site to a really, really long text file. So what this means is my tiny little blog domain that gets 2 hits a year is on a text file on everyone's computer in this room, probably more than once. One's for Chrome, another for Firefox, another for Brave. And this is obviously totally sustainable, where we're going to just include every single domain that's ever going to be on the internet. Now, seriously though, if we do get to a problem where the strict transport security preload list is hundreds of gigabytes long, that's a problem that I'd like to deal with. Because that means HTTPS is ubiquitous and going absolutely everywhere. But that's not the future that we live in now, and so we'll have the browser manufacturers figure out what we're going to do when this file grows too big. But until then, go ahead and preload your site so that the very first time that a client comes and tries to talk with you, they'll be protected by HTTPS before the request ever leaves the browser. Moving on, we got referrer policy. It's one of the more modern, only been around for a couple of years. And so, well, the first thing that I don't like about referrer policy is that it officially codifies in the internet that the original referrer header with 3 R's is in fact a typo that we're stuck with forever, because it is dealt with using the referrer policy with 4 R's. I kind of wish that we had just decided that referrer with 3 R's is a new word that we made up in technology and totally not a typo, and referrer policy blows up that fantasy of mine. That's not the timeline that we're living in anyway. The referrer policy with 3 R's can sometimes leak information about your users to other sites. So for those of you who may not be familiar, basically every time that someone clicks on a link or navigates somewhere else, the referrer policy is sent that says, hey, this person arrived at your site coming from here. And that could leak some sensitive information. So maybe there's very specific query parameters or URI strings that really identify the user. Maybe you're running a website that is, politically sensitive, or might be something that your users would like to be really private about. Or maybe those URIs include very personally identifiable information. I remember there was some researchers out of Germany when they realized that ISPs were selling what they said were, quote, anonymized browsing records of their customers. They went and bought a set and were able to track down individual users because of things like very specific URI strings. Like, there's a profile edit page that you could only get to if you were logged in that includes the name of the profile. So I log into LinkedIn to edit my profile. I get a URI that only I will ever get, and that identifies an otherwise anonymous user. So if you don't want to think or deal with any sort of information leakage, you can use the referrer policy. The specific things that you want to set, again, is going to depend on your specific site, but some good options might include setting it to strict origin, which you just slice off the URI bit, just include the domain name. Or strict origin when cross origin, which will give the full referrer header as they're bouncing around inside of your site, which is usually helpful for things like user tracking. Like various analytics use the full referrer header to help you trace the path that users are going through your site. Marketing, UI folks really enjoy having that information. But when you go across to a different site, it'll slice off that URI information. Or you can say, hey, I don't want to deal with this crap. Just shut it off entirely. Set the no referrer header. That all works. All right, I want to briefly touch on feature policy without going too in depth because, spoiler alert, if you understand content security policy, which is coming up right next, you understand feature policy. It's like content security policy, but for features. And for features, I mean things that are functionality. So whether or not your site's going to use the microphone or geolocation data or video or so on and so forth, feature policy is something that you could use to restrict your site to a small subset of features. The only problem is this something that Google came up with and thought was a great idea, and so is totally implemented across every single browser that Google manufactures, or is based on the Chromium open source version that they release, and everybody else is kind of deciding how this is going to work. So in the past couple of months, Firefox actually added this functionality, but they turned it off by default. So, but then again, everything is becoming the Google Chrome browser, so maybe this will show up sooner than we'll exceed. But know that it's here. This is probably going to be a tool that you can leverage in your toolbox more consistently across your user base within a couple of years. It's just something that's coming down the road. Now with that, I want to do a deeper dive into content security policy because content security policy is the 800-pound gorilla of security headers. Because when we talk about content security policy, the bad thing is somehow, somewhere, who knows what or why, there's some content that's running on your site that you don't want there. And so content security policy lets you lock down to a very specific whitelist what type of content do you want on your site. Imagine this like a big bouncer standing outside of a club with a little clipboard that lists every single piece of content that is invited to come to the party that is your website. And if something shows up that's not on the list, they beat them up and they throw them out, and then they send you a report to let you know who tried to force their way into the party. And when I say content, that's a really generic kind of term. What do I mean when I say content? I mean content. I mean fonts. I mean JavaScript. I mean CSS. I mean images. I mean whether or not there's sub-resource integrity enabled on everything. I mean upgrading HTTP requests to HTTPS. Who gets to embed? You get the idea. If there's something that your website is able to do, more likely than not that there is a content security policy directive for that specific type of content. So let's dive a little deeper and see how we would build this type of a content security policy header. So here's the basic one, where you say the default for any type of content is that it's got to come from me. And that means the specific origin, no other subdomains allowed, and we're going to throw in a report URI, which says, hey, here's the place to send warnings of when I block stuff for you. And then the developer runs up and says, oh, wait, we need to be able to connect to Google Analytics for our metrics stuff. And you say, okay, no sweat. We're going to add another line to the clipboard guest list. Great. Google Analytics, that's a site that you're now allowed to connect to. And everyone's like, okay, fine. Oh, but wait, we have inline JavaScript and this little Facebook Connect widget. And you're like, okay, we're just going to add another line. And you can see how you can be slowly building out a content security policy as your guest list of who's invited to show up at your website. Now, I want to outline the unsafe inline for the script source parameter. It would be our goal as security professionals to be able to get that out of your content security policy, because if you're able to successfully pull that out of your content security policy, entire classes of bugs just die. Your website might have the most horrible cross-site scripting vulnerabilities known to man, but if unsafe inline is not in there, an attacker can shove as much inline JavaScript as they want into your web application, and it's just not going to run. That said, getting rid of unsafe inline is particularly difficult for most organizations. So let's take a look at a couple of real-life examples of how some companies have actually dealt with this. So here's news.google.com. And I want you to notice that they're using unsafe inline in addition to sending a nonce. Now, a nonce has a very specific cryptographic term, so if there's any cryptographers in the audience, I apologize. I'm sure I'm not going to be 100% correct, and encryption involves about getting absolutely everything 100% correct. Thank you so much for your work. But the short version is a nonce is a random, unguessable string of some sort, and it needs to change every single time the page refreshes. And the way this works is if the nonce in the content security policy header is the same as the nonce that's in the script tag, it runs. And if it's at all different, content security policy shoots it in the head. You see why this has to change every single time. If you used a static nonce, which any cryptographer in the world just at the word static nonce, the attacker just drops that same string in. It has to change every single time. And with modern browsers that understand the idea of nonce, it will then ignore the following unsafe inline part of the content security policy. So this lets you fail open. If you have a modern browser, it's protected by the nonce. If it doesn't understand what a nonce is, the stuff's still going to run. You're not going to break your site on older browsers. Another way that you can deal with unsafe inline is by hashing the script and putting that into the content security policy tab. Now, I want to say that I got this exact example from Mozilla's docs, and I really wanted to show this really cool bit of command line foo of echoing it and piping it into SHA-256 just the right way to get the exact thing here, and I couldn't figure this out. So I'm pretty sure Mozilla didn't get it wrong. So my recommendation to you all is to do the same thing that I did, is where you load it up into a browser and you have content security policy, shoot it in the head, and then look at the console errors. There'll be a really nice, helpful thing where it says, hey, by the way, if you want this to run, just drop in this hash. And yeah, much better way to do that. This is really similar to sub-resource integrity, if you're familiar with that, where you specify the hash of third-party resources that you're embedding into your site to say, hey, if this ever changes, stop, do not pass go, do not collect $200, which, by the way, sub-resource integrity, you can mandate through content security policy. Anyway, but to again, go over this, they seem similar, but they're different. So just to recap, a nonce is different every single time that you load the page and can never ever be the same. And the hash is always the same, and you update it any time that you change the script. And both of these are ways to get inline JavaScript protected by your content security policy header. All right, with that, let's take a look at another example, which not just to bag on Facebook, but just to say, as I said, if you are at an organization and you just can't tighten the screws enough to get rid of unsafe inline in your content security policy header, that's okay, all right? You're not, if very, very large companies with way, way bigger application security budgets still can't get rid of unsafe inline in their content security policy, know that you are in good company. Aim for that if you can, but know that while it's technically simple, it can often be really politically difficult to get an entire organization to clean up every single possible instance of inline running JavaScript. And let's take another example of what it looks like in real life. Here is Twitter. That's crazy big. So lots of times various people look at, hopefully you get an idea of how specific you're able to get with this content security policy. That you can tighten things down really, really tight, but in order to do that, you need to have a complete guest list. You need to know everybody that's coming to the party. So oftentimes when I talk to various developers like this, they say, oh wow, that looks really complicated. I'm so glad that we have a security team that can think about this. And at least in my experience, that doesn't work particularly well. I mean, to put it another way, the content security policy header, the only reason that it gets out of bed in the morning is to break stuff, and to break stuff in production. So the greater organizational distance your company has between the people writing the content and the people writing the content security policy header, the more likely it is that it's going to wake up one day and break something in production that we didn't want it to because the left hand didn't quite know what the right hand was doing. So at least for me, a couple of things that have worked well is, well, first off, I think for as much as I love to have developers work on everything, just politically, there's always been some legacy application that was written by someone 17 years ago and no one everybody wants to touch again to try to add a content security policy header. For things like that, the content on that site is probably not going to change too dynamically, and just doing a bit of an audit and then tacking on that header using a proxy or a load balancer seems to work pretty decently well. But for the rest of the things that you're doing with, I, again, recommend to empower your developers to be able to know what a content security policy is and to be able to be authoring it. I'd also recommend that you think really intentionally about whether or not you want your content security policy to fail open or to fail closed. This is the same with many other security tools where you get to decide, depending on how you want to deal with things, fail open or fail closed could both be the correct security decision, but it depends on the context. And the default source, I'll go into this in depth in the next slide, the default source is where you decide whether or not your content security policy fails open or fails closed. And the third thing that I recommend, which we'll go over in a little bit again, is use the report-only header in order to figure out what's going to happen when you make a change or an edit to your content security policy. So what do I mean about this fail open or fail close? Imagine that there's a new type of content that we all want to be running on our site called foobar. And so browser people get together and we're like, great, we're going to add a foobar source directive to the content security policy. And you're like, great, I use foobar. In fact, I use foobar from superfoo.com. I'm just going to go ahead and add that line into my content security policy. What you have done is 100% correct, 100% to spec. But the problem is that if you have an older browser that hasn't been updated to understand what the foobar source is, it's just going to ignore that directive entirely. And once it's ignored the directive entirely, it's going to fail back to the default source. So you can either say that your default source is none, I've whitelisted every possible content that I want, and if it's not on the list, kick it out, or set default source to star, which will still protect your site. For every single part, every single directive that the browser understands, it is restricted to the whitelist. And then everything that it doesn't understand, it just lets through. Again, I'm not going to tell you which of these two modes is correct for your application. Just know that you can write a 100% perfect, 100% to-spec, perfectly, exquisitely crafted content security policy and still break something in production you weren't meaning to. Not because of your fault, but because that's the ecosystem of browsers that we have to deal with. And I can say the other thing that's worked really well in the places where I've tried to implement this is using the content security policy report only header, which if you understand content security policy, you understand the report only header. You just tack those two words on at the end and it looks and acts and feels 99% the same as content security policy. It just doesn't break anything. And when it does that, it'll still send you the report. Both the content security policy and the report-only header will send this little JSON blurb that's very helpful. It tells you exactly where the thing was blocked, what directive it violated that caused it to be blocked, and lets you know what the policy it saw on that page was. And the only part that's going to be different is that disposition down at the bottom, where either it's just going to be reporting and we let this go through, or it says enforce, where I took it out back and shot it in the head. So that's content security policy. Again, we're trying the slide-do thing. If the proctor wants to get up whatever questions that we have here at the time. If there's not enough time for questions, go ahead and get my contact information off there. Again, go to this event in Sketch. You can download the PDF of the slides. And thank you guys so much for your time. That's what I got. I don't know, do we have time for questions?
We have about 3 minutes for questions. Again, go to slide.do, and the code is BSidesSF 2019. They'll come up over here. Our first question is, what about cores?
What about cores? So CORS is another header that you can be setting. So if you're familiar with same origin policy, this is basically a default in most browsers that restricts content for operating in the same kind of same origin. And this helps protect against cross-site request forgery, where you go to attacker's site and it tries to impersonate you on some other site. CORS is something that loosens the same origin policy. It doesn't tighten it. So I don't necessarily, it's related to security in so much that if you set it wrong, it will help shoot yourself in the foot. But it's not something that I find, the default is more secure, at least to my understanding. Do we have more questions? Or are we out of time?
We have a little bit more time, but no more questions.
More question in the room?
Yes,
Yeah.
we got, in the room?
You mentioned that not all the browsers support this. What about kind of browser-like tools like curl or wget? Do any of these have problems with this?
So for things like curl or wget, it will show you the header that comes back, but because it's not like executing JavaScript or loading images, it's not really something that it's looking at. Like, it's going to give you the response that the tool gets back, but isn't necessarily. I don't know off the top of my head the types of attacks that you would do against curl, except don't pipe it straight to bash. But the content security policy is not entirely applicable to command line tools like that. Yep, it's designed for kind of full-featured browsers. Again, if I'm totally wrong, you want to yell at me, there's my contact information. I'm going to be hanging outside. Come say hi. Thanks, you guys, for the time so much.
All right. On behalf of B-Sides San Francisco, I'd like to thank you. Let's have a round of applause for Benjamin.